At 12:18 UTC on October 3, 2024, the Sun unleashed an X 9.0 flare. It was the strongest solar flare of the year and the most powerful flare of solar cycle 25 at that time. But the brilliant flash was only the first messenger. In this video, we will follow the same eruption through 3 different eyes: AIA 304 angstroms, LASCO C2, and LASCO C3. Each instrument sees a different part of the story. The X 9.0 classification comes from the GOES satellites, which measured the flare's X-ray energy near Earth. The flare began at 12:08 UTC. It reached its peak 10 minutes later at 12:18 and ended at 12:27. Our first view is not an X-ray image. It is extreme ultraviolet light captured by NASA's Solar Dynamics Observatory. AIA 304 angstroms reveals the Sun's lower atmosphere along with cooler erupting material. Near the lower center of the solar disk, active region 3842 suddenly brightens. Plasma lifts away from the surface, while the surrounding atmosphere responds to the eruption. The light from this flare crossed the 150 million kilometers between the Sun and Earth in about 8 minutes. But the ejected plasma moved much more slowly. About 30 minutes after the flare's peak, the eruption entered the field of LASCO C2. LASCO is a coronagraph. Its black disk blocks the overwhelming brightness of the Sun, creating an artificial eclipse so the faint corona can be seen. Watch as the bright front expands around the occulting disk. This is the coronal mass ejection, a vast cloud of magnetized plasma moving away from the Sun. Because the expanding front surrounds much of the occulting disk, scientists describe it as a halo CME. A halo shape often suggests that some material is traveling along the Sun-Earth line. However, the shape alone cannot tell us exactly how strongly the eruption will affect Earth. Now, the view widens. LASCO C3 follows the eruption much farther from the Sun. The blue field contains stars and the extended corona, while the CME spreads outward and gradually leaves the inner solar system behind. This is why space weather forecasters need more than one instrument. The flare's light gives an immediate warning. The coronagraphs reveal the slower cloud that may arrive later. NASA's event record shows that a shock associated with this eruption reached near-Earth space on October 6th at about 6:55 UTC, almost 3 days after the first flash. 1 eruption, 2 kinds of messenger, 3 views of the journey, and together they turn a flash on the Sun into advance warning for Earth. If you want to follow the next messenger, subscribe to Galaxy 387. In the next episode, we will answer a question that is often misunderstood. What is the difference between a solar flare and a CME? And which one matters more to Earth?